Hello students, welcome to our student support program for grade 11 additional mathematics. Today you will learn how to apply integration to the evaluation of plane areas. So let's begin. In an earlier video, you have learned how to apply integration to evaluate an area. For example, to calculate the area of this shaded region, we are going to integrate f of x with respect to x from the limits a to b. Today, you will learn further application of integration to evaluate area in different cases. Case 1, area between a curve and y-axis. How do we calculate the area of this shaded region? Here, we are going to integrate g of y with respect to y from the limit c to d. Here you will notice that the shaded region is with respect to the y-axis. Therefore, to evaluate the area, we will integrate with respect to the y-axis. And in order to do so, note that the function has been rewritten with x as the subject, that is, from y is equal to f of x to x is equal to g of y. Let's apply this rule to example 1. Find the area of a shaded region. To calculate the area of a shaded region, we are going to integrate cube root of y with respect to y from 1 to 8. First, we are going to rewrite y with power 1/3 to get integration of y to the power of 1/3 with respect to y from 1 to 8. Integrating this function, we get y to the power of 4/3 divided by the power, which is 4/3, from 1 to 8. Substituting the limits, we get 3/4 into 8 to the power of 4/3 minus 1 to the power of 4/3. Evaluating this, we get 45/4 units square. Case 2. Area between a curve and a line. To find the area enclosed here, we are going to integrate f of x with respect to x from a to b minus integration of mx plus c with respect to x from a to b. Note that both integrations have the same limits, so we can group them together to get integration of fx minus mx plus c with respect to x from limits a to b. Let's apply this rule to example 2. Find the area enclosed by the curve y is equal to 4 minus x squared and the line y is equal to x plus 2. To calculate the area enclosed, it is equal to integration of 4 minus x squared minus x plus 2 with respect to x from limits minus 2 to 1. First, we are going to simplify the function to get integration of 2 minus x squared with respect to x from limits minus 2 to 1. Integrating this function, we get 2x minus x squared over 2 minus x cubed over 3 from negative 2 to 1. Substituting the limits, we get 2 into 1 minus 1 to the square over 2 minus 1 to the cube over 3 minus 2 into minus 2 minus minus 2 to the square over 2 minus minus 2 to the cube over 3. Evaluating this, we get 9/2 units square. Case 3. Area between two curves. To calculate the area enclosed here, we are going to integrate f of x minus g of x with respect to x from the limits a to b. Note that f of x is greater than g of x. Now, this rule is still true if parts of either curve are below the x-axis. To calculate the area enclosed, we are going to integrate f of x minus g of x with respect to x from limit 0 to a. Note that f of x is greater than g of x. Let's apply this rule to example 3. The diagram shows part of the curve of y is equal to 8x squared minus x cubed, which meets the x-axis at the origin O and at the point A. The line y minus 2x plus 16 is equal to 0 passes through A and meets the y-axis at the point 0 minus 16. Find the area of a shaded region bounded by the curve y is equal to 8x squared minus x cubed. The line y minus 2x plus 16 is equal to 0 and the y-axis. First, to calculate the area of a shaded region, we need to calculate the coordinate A. The x-coordinate of A from the line y minus 2x plus 16 is equal to 0. On the x-axis, y is equal to 0. Replacing y is equal to 0 in the line, we get 0 minus 2x plus 16 is equal to 0. Solving for x, we get x is equal to 8. Therefore, the x-coordinate of A is 8. Now we are going to calculate the area. The area of a shaded region bounded by the curve y is equal to 8x squared minus x cubed. The line y minus 2x plus 16 is equal to 0 and the y-axis is equal to integration of 8x squared minus x cubed minus 2x minus 16 with respect to x from 0 to 8. First, we simplify the function to get integration of 8x squared minus x cubed minus 2x plus 16 with respect to x from the limits 0 to 8. Integrating the function, we get 8x cubed over 3 minus x to the power of 4 over 4 minus 2x squared over 2 plus 16x from limits 0 to 8. Substituting the limits, we get 8 into 8 to the power of 3 over 3 minus 8 to the power of 4 over 4 minus 2a to the power of 2 over 2 plus 16 into 8 minus 8 into 0 to the power of 3 over 3 minus 0 to the power of 4 over 4 minus 2 into 0 to the power of 2 over 2 plus 16 into 0. Evaluating this, we get 405 1/3 units square. Now that we have done a few examples for you, here are some exercises for you to practice. So students, today you have learned how to apply integration to the evaluation of plane areas. I hope you have enjoyed it. See you next time.